Hello viewers, welcome to my channel. Today we will solve some mathematical problem on microscopy. It is very important topic in microbiology. For CSR NET, IC1 NET, GATE, DBT exam, the question related to this topic is very important. Some key notes are also mentioned here which will be beneficial for you. So stay tuned in this video. The first question. What will be the value of the numerical aperture if the half aperture angle is 58 degree and the objective is used in air for the process of light microscopy? Consider sin 58 degree is equal to 0.85 and the refractive index of air used is 1. To solve this question, we have to consider the formula Na is equal to small n sin theta, where Na is equal to numerical aperture, n is equal to refractive index, theta that is half aperture angle here is 58 degree. Here sin 58 degree mentioned as 0.85 and the refractive index of air used is 1. So the numerical aperture Na is equal to 1 into 0.85, that is 0.85. So the answer will be 0.85. That is the numerical aperture will be 0.85. Now, what is refractive index? Refractive index is a measure of bending of light ray when passing from one medium to another, whereas numerical aperture is the number associated with the light gathering capacity of an objective lens or condenser lens. Next question. What will be the maximum resolution of blue light if oil immersed objective is used for the process of light microscopy? As you know that the maximum resolution D is equal to lambda divided by 2Na. This is the Ab's equation known as, where lambda is equal to wavelength of light, that is 450 nanometer, as the wavelength of blue light is 450 nanometer. We have already mentioned that Na is equal to small n 9 theta, where n is the numerical aperture, small is the refractive index, theta is the half aperture angle. Here it is 70 degree. Hence the base angular aperture of the objective lens is 70 degree. So here theta is 70 degree. Sin 70 degree is equal to 0.94. And the refractive index of immersion oil used is 1.50. So the maximum resolution D is equal to 450 divided by 2 into 1.50 into 0.94. That is 159 nanometer. So the maximum resolution is 159 nanometer. Now let's discuss about the resolution. Resolution refers to the ability to see two items as separate and discrete objects that are close together. Next question. What will be the value of numerical aperture if the half aperture angle is 58 degree and the oil immersed objective is used for the process of light microscopy? Consider sin 58 degree is equal to 0.85 and the refractive index of immersion oil used is 1.50. Again, we have to consider the formula Na is equal to small n 9 theta, where Na is equal to numerical aperture, small n is equal to refractive index, theta is the half aperture angle, here it is 58 degree, and sin 58 degree is 0.85, which is mentioned here. And the refractive index of immersion oil used is 1.50. Putting this value, the value comes that 1.275. But we have to answer up to one decimal place. So 1.275 is approximately 1.3. So the value of numerical aperture is 1.3. Next question. Determine the wavelength of visible light that has frequency of 6.24 into 10 to the power 14 Hz. To answer this question, we have to consider the formula, that is wavelength of light lambda is equal to V/f, where f is equal to frequency of light, which is mentioned here is 6.24 into 10 to the power 14 hertz, and v is equal to velocity of light. We know that the velocity of light is 3 into 10 to the power 8 meter per second. Putting this value, lambda is equal to 4.8 into 10 to the power minus 7. So the wavelength of visible light is 4.8 into 10 to the power minus 7. Next question. What do you mean by resolution of a bright field microscope is 0.2 micrometer? It means that a bright field microscope can distinguish between two dots or two things about 0.2 micrometer apart. Now coming to the most important things. Here some keynotes are mentioned and you just remember this all things. First is the refractive index of immersion oil used is 1.50. Next, the refractive index of air is 1. So the refractive index of air is 1, whereas the refractive index of immersion oil used is 1.50. In some question, the refractive index of immersion oil or the air is mentioned. Sometimes it may not be mentioned. So you just remember these two things. Next is the base angular aperture of the objective lens is 70 degree. And next, coming to the part of the numerical aperture equation. Numerical aperture Na is equal to small n sin theta, where n is the refractive index, theta is the half aperture angle. And the maximum resolution D is equal to lambda divided by 2Na, where lambda is equal to wavelength of light. To answer any kinds of mathematical problem, you have to remember the formulas. So please remember these formulas. As the D becomes smaller, the resolution increases. D becomes smaller as the wavelength of light used is decreases and the numerical aperture increases. When we get the greatest resolution is obtained using a lens with the largest possible numerical aperture and the light of shorter wavelength. So if we use the shorter wavelength of light, we will get the greatest resolution. Or if we use the largest possible numerical aperture, we will also get the greatest resolution. So please remember these keynotes. These are very, very important. If you remember all these things, it will be very easy for you to solve the mathematical problem related to this topic. Thank you. Please like, share and subscribe to this channel.